Saxon Math, Lesson 1, Classifying Real Numbers. When we start talking about algebra, algebra is broken down into whole new sets of numbers. Algebra completely changes what numbers actually are. Real numbers is all numbers. Real numbers is broken down into two sections, irrational and rational numbers. Let's talk about rational numbers first. The three sets of rational numbers are natural, whole, and integers. Natural numbers start at 1 and continue moving forward. 1, 2, 3, 4, and continues. Whole numbers start at 0 and moves forward. 1, 2, 3, and continues. Integers include negative numbers, like -2, -1, 0, 1, 2. But they also continue not only on the positive side, but also the negative side. If you take a look at these numbers, you can notice that certain numbers go in all three sets. The natural numbers 1, 2, 3, 4 are part of the whole numbers, which actually are part of the integers. If you go back to the original chart, you can notice that the natural number circle is located in the whole number circle, which makes natural numbers actually whole numbers also. If you notice the natural numbers and the whole number circles are located in the integer circles, that means natural, whole, are actually integers. And if you notice that all three circles are located in the square of the rational number, that means all three numbers are considered rational. Now, let's talk about the difference between rational numbers and irrational numbers. So we've talked about before that the natural, whole, and integers are considered rational numbers. But there are also decimals that are considered rational numbers, or fractions that are considered rational numbers. 1/2 is a rational number. 0.5 is considered a rational number. And numbers that repeat, 2.3 repeating, is a rational number. Irrational numbers are decimals, but these decimals continue to go on forever and ever. They don't stop and they don't repeat. Pi is a very good irrational number. So is the square root of 2. These are numbers, when put into the calculator, are numbers that will go on and never actually stop. When we were talking about different types of numbers, I kept calling them a set. There are actually two different types of sets that we can talk about: the finite set and the infinite set. The finite set is the numbers that don't continue. It just stops. For example, 2, 4, 6, and doesn't continue. The infinite set continues. Let me give you an example. 2, 4, 6, 8, and it continues. we have something called an empty set. An empty set have no numbers located in that set. It looks like this. A set of brackets with no numbers, or a circle with a line through it. If you notice, each set actually has brackets surrounding that certain set. It makes it separated from different sets. When you have more than one set, there are two different ways to compare the numbers in those sets. You have the intersection of sets and then union. The intersection of sets is a set of numbers that is located in all the sets that are given. The symbol that means intersection of set kind of looks like an N. Now the union is a set of numbers that show every single number that's located in all the sets given. The symbol for union looks like a U. Let's do an example. Here is the example. A intersection of B and A union of B. And if you remember, we learned the symbols of intersection and union are what's given in this example. So, we have set A and set B. The number for set A is 2, 4, 6, 8, 10, 12, and B is 3, 6, 9, 12. When we solve this equation, we write it out just exactly the way it shows in the example. A intersection of B are what numbers? Now we learned that intersection are the numbers that match. Take a look at set A and set B and find the numbers that match in both sets. If you notice that 6 match and 12 match, then that's exactly what the answer is going to be. 6 and 12. Now, the second part of this equation is A union of B. So we take a look at both set A and set B, and the answer is going to be all the numbers that's in both sets. So take a look and see if you notice all the numbers that are given in both sets. You should notice the numbers in both sets would be 2, 3, 4, 6. But you remember, 6 matches in both. But because 6 matches, we only write 6 once, not twice. 8, 9, 10, and 12. And we write 12 only once. If you have any questions, make sure you see me in class. Y'all have a great night.